The only way to learn mathematics is to do mathematics. Good morning students, I am Chandrakant Tiwari. Welcome to my YouTube channel Usha Learning Classes. We are going to conduct video classes of class 10th mathematics CBSE board in a series of videos. Today we are going to study about real numbers class 10th chapter 1 and we will cover in this video real number, include division lemma, include division algorithm, CBSE board question paper solved and one assignment. Let us take a quick recap of numbers. First, natural numbers. These are all counting numbers starting from 1. For example, 1, 2, 3, 4, 5, 6, 7, 8, etc. Second, whole number. All counting numbers together with 0 form the collection of whole numbers. For example, 0, 1, 2, 3, 4, 5, 6, etc. Third, even number. Numbers divisible by 2 are known as even numbers. For example, 2, 4, 6, 8, etc. Fourth, odd number. Numbers not divisible by 2 are known as odd numbers. For example, 1, 3, 5, 7, etc. Next is integers. All counting numbers, negative of counting numbers and 0 form the collection of integers. For example, minus 3, minus 2, minus 1, 0, 1, 2, 3, etc. are integers. Sixth, prime numbers. Numbers divided by 1 or itself only are known as prime numbers. For example, 2, 3, 5, 7, etc. Note, the first prime number is 2. 1 is not a prime number. Next is composite numbers. Numbers divided by 1 itself and any other number are called composite numbers. For example, 4, 6, 8, 9, etc. are known as composite numbers. Eighth, rational numbers. The numbers of the form of ratio P by Q, where P and Q are some integers and Q not equal to 0, are called rational numbers. It terminates after a definite decimal expansion. For example, 30 by 4, you see 30 by 4, it terminates after 5, 7.5, it terminates after 5. And also it may be non-terminating but repeating. For example, 10 by 3, that is equal to 3.333333. It is repeating and not terminating. These are the properties of rational numbers. Now ninth, irrational numbers. Non-terminating and non-repeating numbers are called irrational numbers. For example, root 2, root 3, root 5, root 7, pi, etc. are called irrational numbers. Irrational numbers are those numbers that cannot be written as the ratio of two integers. Real numbers. Real number is a number that represents on a number line. It is denoted by capital R. Real numbers include all numbers. For example, natural number, whole number, rational number, irrational number, integers, etc. Now we come to number line. We see all integers are denoted here. 0, 1, 2, 3 and negative integers minus 1, minus 2, minus 3. And we can see, we can plot a number like 0.5, 1.5, 2.5 in decimal form. And root 2, root 5, etc. are irrational numbers. So we can plot every number on number line and it is denoted by capital R, that is real numbers. Let us proceed further to our next topic, Euclid's division lemma. What is lemma? A lemma is a proving statement used for proving another statement. It has already proved and then we use it to prove another statement. That is lemma. Now Euclid's division lemma is stated as for any two given integers a and b, a greater than b, there exists a unique whole number q and r such that a equal to bq plus r, where r is greater than equal to 0 and less than equal to b. Note, q and r can also be 0. Means q and r can also be 0. Also we can write it as dividend equal to divisor into quotient plus remainder. Now we can see some examples of Euclid's division lemma. We have given two numbers, two integers, positive integers, and we have to express it as Euclid's division lemma. The first number is 10 and 3. This is our first example, 10 and 3. We can see 10 is greater than 3, so we can write it as 10 equal to 3 into 3 plus 1. 3 3 is 9 plus 1, 10 equal to 10, that is. Clearly we can see A equal to BQ plus R. Here A is 10, B is 3 and R is 1. And Q of course is 3. Move to our next example, 4 and 19. Since 19 is greater than 4, we can write it as 19 equal to 4 into 4 plus 3. Our next example, 81 3. 81 is greater than 3, so 81 equal to 3 into 27 plus 0. Now come to our next topic, Euclid's division algorithm. Now first we understand what is algorithm. Algorithm, it is a series of well-defined steps which gives a procedure for solving a type of problems. And through this algorithm, we define our Euclid division algorithm in the following steps. Now, Euclid division algorithm. To obtain the HCF, highest common factor HCF, of two positive integers a and b such that a is greater than b is in the following steps. Step number 1. Apply the Euclid division lemma to a and b so we can get the numbers q and r such that a equal to bq plus r and r is greater than equal to 0 and less than b. Step number 2. If r equal to 0, q is the HCF of a and b. If r is not equal to 0, apply the Euclid division lemma to b and r. Step 3. Continue the process till the remainder is 0. Our main aim is to get remainder as 0. And when it comes to 0, the divisor at this stage will be the required HCF. We will see some CBSE board exam questions solved. Let us start question. Using Euclid division algorithm, find the HCF of the numbers 867 and 255. We already see what is Euclid division algorithm and what is Euclid division lemma. Let us start. Since 867 is greater than 255, therefore we divide 867 by 255. Let us do that. 255, 867, 3 times. 765. 255 3 is 765. And remainder is 102. Now remainder is not equal to 0. We again divide 255 with 102. Let's do it. 255 2 times 204 1 5. Remainder is not equal to 0. We will divide divisor 102 by 51 again. 102 2 times 102. Since remainder is 0, So our required HCF is 51. Let us do in systematic way. We divide 867 by 255 by using Euclid's division lemma. Lemma 867 equal to 255 into 3 plus 102. Remainder not equal to 0. Therefore, again 255 equal to 102 into 2 plus 51. Remainder is not equal to 0. Remainder not equal to 0. Therefore, again by Euclid division lemma, 102 equal to 51 into 2 plus 0. Hence here remainder is 0. Remainder is 0. So the divisor of this time, divisor of this step is our required HCF, is our required HCF. Hence 51 is HCF of 867 and 255. To our next question, B. If the HCF of 65 and 117 can be written as 65m minus 117, find the value of m. We have to find the value of m. Before that, we have to find HCF of 65 and 117. And we can clearly see 117 is greater than 65. So, since 117 greater than 65, we divide 117 by 65 and by Euclid's division lemma, we can write as 117 equal to 65 into 1 plus 52. Now, since remainder is not equal to 0, since remainder not equal to 0, again 65 equal to 52 into 1 plus 13. 65 equal to 52 into 1 plus 13. Since remainder not equal to 0, again 52 equal to 13 into 4 plus 0. So we can see here remainder is 0. Now our remainder is 0. So required HCF of 65 and 117 is 13. 13 is the new HCF. Now we can see in question given as given in question 13 equal to 65 m minus 117 or 130 equal to 65 m or m equal to 2. Let us move to our next question. So that every positive odd integer is of the form 4q plus 1 or 4q plus 3 for some integer q. Let us try to solve it. Let us assume let n be any odd positive integer on dividing n by 4 we get q and r as quotient and remainder. By applying Euclid's division lemma, Euclid's division lemma, we can write n equal to 4q plus r, where r is greater than equal to 0 and less than 4. Clearly we can see. Now since r can be 0, 1, 2, 3. It cannot be 4. It is less than 4. So we can proceed to our next step. We have n equal to 4 cube plus 0 or n equal to 4 cube plus 1 or n equal to 4 cube plus 2 or n equal to 4 cube plus 3. Clearly n equal to 4 cube and n equal to 4 cube plus 2 are even numbers. And we have to find odd numbers, not even numbers. So we can write, since n is an odd number, since n is an odd number, therefore n not equal to 4 cube and n not equal to 4 cube plus 2. Hence our required odd numbers are is 4 cube plus 1 or 4 cube plus 3. That is hence proved. Now today's assignment question. An army contingent of 616 members is to march behind an army band of 32 members in a parade. The two groups are to march in the same number of columns. What is the maximum number of columns in which they can march? Please note down the assignment question. I read once again. An army contingent of 616 members is to march behind an army band of 32 members in a parade. The two groups are to march in the same number of columns. What is the maximum number of columns in which they can march? Try to solve it. If you solve, give your answers in comment section. And if you can't, then you can see the solved assignment in our next video. Before concluding today's session, I just want to quickly say that if you like this video or you want more videos on maths, then please subscribe my YouTube channel and hit like button, and do not forget to share and comment guys. Thanks for watching.